like to welcome Marc from Eaton, who's going to give you every single bit of information you will ever need about AFDDs. Ladies and gentlemen, Marc.
Thank you. Good morning, everyone. So I'm Marc Gaunt. I'm the segment marketing manager for Eaton in the UK. So we're just going to spend about 15 minutes now talking about arc fault devices. So what we're going to try and cover off is a little bit of the backdrop about why we see some recommendations around arc fault devices in the 18th edition, some of the statistics that sit behind it, and how we may be able to interpret some of those recommendations as well. So 1st of July last year, I think, was when the first draft of public comment came out, as Gary mentioned earlier, on the 18th edition. That was the first time we saw these recommendations around the use of arc fault devices. The fact that the 18th edition was coming this year, working with the industry, we know it's a period of significant change. But what we didn't expect was that we were then going to have the tragic events of Grenfell that happened 14 days later. So on the back of that, what we sort of have within the industry now, when we look at it more widely, is we have the 18th edition coming through. We also then have a number of further assessments of building safety in the UK. And the main one I'd probably mention is the Hackett report. So if you're not familiar with it, you can go online and download it. So this is Dame Hackett looking at post-Grenfell and looking at the building regulations in the UK and providing some views on that based on industry experts. There's a number of different points within the Hackett report. We'll probably cover some of those off later on. But one of the things I will mention is that within the Hackett report, she refers to technology that we can use post-event in the event of a fire, but also pre-event technology as well. So how can we actually stop a fire in the first instance? So two of the technologies that I mentioned are sprinkler systems and also compartmentalisation of buildings. I'm not suggesting those aren't good things. I think they really are. I think one of my challenges probably back is, did they actually prevent a fire? And the reason for mentioning those points is that when we talk about arc fault devices, it is a technology, when we cut to the point, which is designed to prevent fires in the first instance as a result of an electrical fault. So that's a little bit of the backdrop to arc fault devices. So if we start to then look at a few statistics, and we'll talk about statistics in the UK, in Europe, a little bit so more widely as well. The good news is that actually the number of fires in the UK has reduced over the last 10 years. So reduced from sort of 100,000 fires to in the region of 56,000 fires. However, although the incidence of fires has actually reduced, the cost of fires has actually gone up significantly. So if we look at residential buildings, the cost has tripled over the last 10 years. And then if we look in commercial buildings, 2016 was an all-time high for costs of fires in commercial buildings. So the rate of fires has gone down, but the costs associated with them has actually gone up. And then if we actually look in the UK what has caused those fires, if we look at the Association of Building Insurers, they estimate that somewhere in the region of 50% of fires in commercial buildings was the result of some form of electrical fault. So, so when we look at it, the electrical industry can play a major part in fire prevention. Looking more widely, the numbers do vary, look at country to country, but if we look in Europe, this is a statistic from the Geneva Risk Association. So they estimate across Europe, electrical fault cause about 25% of fires. So 50% on one side, 25% on the other. The point is, within the electrical industry, we can really play our part to prevent fires. So, onto the 18th edition itself then. So, arc fault technology is not actually new. So if you go online, if you Google AFCI, that'll probably take you onto a number of American websites. And in the US, the technology or something very similar has been used now for about the last 20 years. So in the US, it's been used extensively for some time. Adoption has actually grown, and we'll also come back to that. But it's not just within the US. So in Canada, the technology has been used for some years. In Germany, for certain applications, it was mandated about, 18 months ago now. And there's a number of other countries within the EU where they're looking towards this technology. So technology is not new, it's existing technology. Its recommendation within the UK is new, but we do have other countries that have already adopted this technology. But then when we look within the 18th, we have this new recommendation, so it's 421.7, and that is the recommendation of arc fault technology. Whether recommendation is good or not is probably open to some discussion, but going back to Gary's point, it is a recommendation. It is not required anywhere, so it is open to interpretation. And as we'll come on to now, it's probably based on interpretation, based on some risk assessment. So we do have, the good news is we do have some guides about where arc fault devices can provide the most benefit. Again, interesting point. So the recommendations we've got up on the screen, they are from guidance notes for the 18th edition. There is a really good guide that Beamer have also produced more widely on arc fault devices, and those recommendations are captured in there as well. That guide, by the way, is available for free of charge download. So if you work in education, if you work in colleges, etc., it's a really good source of information. If you use LinkedIn extensively, if you just sort of look for my name, I did put it on there a couple of days ago, so you'll be able to download that guide. The other point I'll mention as well is that the risks that we're going to come on to, the interesting point is there are some building types and some applications of buildings where the guidance notes recommend the use of arc fault devices. Interestingly, if you go back to the Hackett report, which is a completely separate document, those buildings of higher risk are referenced almost the same within the Hackett report. So we have something within the 18th edition where it talks about the recommendation of arc fault technology. If you look at the Hackett report around higher risk buildings, they're very similar in nature. So those building types, so the first one, as Gary mentioned, is buildings where we have sleeping accommodation. You could think of that as your 2-bed, 3-bed semi-detached house, but we can also think of things like student accommodation, hotels, as Gary mentioned earlier, maybe sheltered accommodation. Again, it is a recommendation, not a requirement. The way I tend to think of this one is more around what happens in the event of a fire. So what is, I suppose, what are the challenges about evacuating somebody from that building? So personally, if it was me, if it was a smaller residential dwelling, it might be something where you want to speak to your client about whether they think it's appropriate or not. Once you get onto a larger building where there is a higher risk in the event of a fire, it's more complex to evacuate people. That could be something where arc fault technology is much more beneficial. The second application is buildings where their construction introduces some form of risk. So it could be sort of a wooden sort of frame building, for example. We then have buildings where they're used introduces some risk. So if there's flammable materials being stored, for example. And then the final, suppose, guidance around use of arc fault devices is buildings where there is some form of irreplaceable object. So if it was a museum or a gallery, for example, we might want to put that extra layer of technology into that building. So that's a little bit about sort of the backdrop. We'll now quickly talk about the sort of technology. So the first point is that arc fault technology, I think Gary mentioned this briefly earlier, it doesn't replace anything that we've used historically. And we can think about it in terms of layers within sort of safety in products and within installations. So we could argue that the best sort of first level of safety is around good workmanship, which hopefully you guys are all really good at. So that's one of our first basic levels of safety within an installation. If we then look at products, we've got then sort of enclosure of live parts, so the actual enclosure that wraps around a product. And then we get into protective technologies. So we have overload protection, within, or sort of short circuit protection within an MCB, for example. We then have residual current protection, which the adoption has increased over the years. And then we have arc fault technology, which sits over the top of that. So it's not that arc fault technology replaces any of those layers of safety. It is extra layer of safety that sits above those existing ones. And as Gary mentioned earlier, it's a technology where it is looking for a higher resistance arc fault. So if we've got an arc fault, and we'll come on to how those occur, it's not something where we'd expect an MCB to disconnect or an RCD for that matter, but there could be enough energy present to introduce a fire within that building. So that's what an arc fault detection device is looking for. How do arc faults occur? You may well have seen a number of them on installations over the years. We'll come on to what statistically what are the most common causes or types of arc faults, should I say. But at a headline level, it could be where we've got crushed cables, not necessarily within the fixed infrastructure of a building. If we've got a portable appliance, it's downstream of arc fault device, again it would detect it. It could be something where we've pierced the insulation on cables. So you've got a cable running within a wall, you drill that wall and you happen to nick a cable, that could introduce an arc fault. And then you've got other potential risks, such if you've got some form of rodent infestation, general wear and tear on the installation, bent plugs, sockets, damage to sockets, etc. These are all potential causes of arc faults. So that's just a background of how we might get an arc fault within a building. So then the type of arc faults, and this is relevant when we come on to ring mains, which I'll mention in a moment, which is a question that we get quite frequently. So broadly, we have 3 types of arc faults. So the first one, which is most common, is a serial arc fault. That's where we've got the live conductor and there's a break within the live conductor itself. And statistically, it's about sort of circa 90% of faults where we expect it to be some sort of series arc that takes place. We can then get a parallel arc between live and neutral conductors, so typically sort of 10%. And then less likely when it comes to arc faults is some sort of arc fault between the live and protective earth conductor. So there's the type of arc faults we might have within an installation. The reason for mentioning ring mains before is we still use ring mains in the UK. It's a bit of a nuance, I think, in the UK compared to other countries. So we do have the question quite commonly, do arc fault detection devices work on ring mains? The answer is they do, but it depends. So again, this beamer guide that's available, if you download that, it sort of covers it. It's a good point of reference to go back to. But the answer is, if we get a particular type of arc fault with an installation, so if we get a parallel arc fault, then an arc fault detection device is going to detect it, we'll disconnect that circuit. If we get a series arc fault within a ring main, it may not detect that, but is not deemed to be a risk because we get a flow of current around the other leg, so it is not deemed to be a risk within that installation. But if you forget those sort of scenarios, again, if you go back to the beamer guide, sort of beamer guidance notes, there's about a page that sort of covers that off in a little bit more detail. So types of arc fault devices and what does that mean for enclosures? Devices themselves you will find will vary from manufacturer to manufacturer. So for some manufacturers it will be a device which clips onto the side of an existing MCB. In other cases it could be a combined unit where you've got overcurrent protection and arc fault as well. In the case of Eaton, it's actually what we refer to as AFDD+. So you can imagine it as an RCBO with arc fault protection on there as well. So it's basically all that technology built into one. I know within your packs, you've got some information from Siemens, Electrium. So they've got those guys with a slightly sort of different take on it. It's worthwhile mentioning, arc fault detection device, AFDD. It's not an Eaton term, it's a generic term. But just to mention, different manufacturers will approach it in a slightly different way. So, as well as ring mains being quite unique to the UK, some of the enclosure systems that we use are relatively unique as well. So within residential applications, we use metal clad consumer units now. We might use some form of split load configuration. The reason for mentioning that is how you may choose to use arc fault detection devices until there are specific requirements may vary project to project. So it could be you look at a particular building and you decide that you're going to use arc fault detection devices on all outgoing ways. And as Gary mentioned earlier, just to repeat, it is for application on outgoing ways, not on main incomers. However, you may take a sort of more balanced view. We've got an example sort of upstairs if you want to see it afterwards, where you could take an existing sort of distribution board. You may deem that the ring mains are a higher risk due to portable loads that are on that circuit. You may just choose to put arc fault devices on those circuits, and on other circuits you may use RCBOs or MCBs. So the point is, you can take a balanced approach to their use. You can do a risk assessment, and within that risk assessment you may sort of deem there's a higher risk for the building overall, or you may choose to pick out certain circuits where it is most relevant. I have a view, by the way, which I'll give you on the adoption of arc fault detection devices. There is not a requirement to use them. So in my mind, I don't sort of see that your local wholesaler is going to be selling thousands of them next week. More what I expect is that this will be more specification-led, so it could be a consultant where they're recommending it. We have seen interest from local authorities, housing associations, for reasons we can imagine, so again through specification, or it could be through you've got a project, it may even be a small project where you speak to your client, you both agree that it's a good thing to put into place and you choose to do that on that particular project. So today, I think we'll see it coming more and more, but I think it'll be more project orientated to start with, and it's through risk assessment. So just to finish off, one technical slide, and then I think we just have to do a quick summary on some statistics to finish. So the technology itself, very simply the way you can think of it, is an arc fault detection device, is looking at a sine wave on the circuit, and it is looking for a signature or a thumbprint of an arc fault. So we'd expect that we sort of get arcs quite regularly on a circuit. If you've got some form of rotating machinery, you get naturally occurring arcs. The way arc fault detection devices are designed to work is it is looking for the specific characteristics of an arc fault. So it's the pattern, the duration and how often that is repeated. So they are capable of distinguishing between what is a fault and what is a naturally occurring arc. So just to finish, some statistics first of all, and this goes back to the US as I mentioned briefly. Yes, in the US, different installation practices, different building types, different age of buildings. But I mentioned before, arc fault devices have been used for some years. I think as of now, there are 48 states where arc fault devices, or AFCIs as they're referred to, are mandated. So that adoption has grown. One of the reasons for that is there was a report done in 2011 by the National Fire Protection Association, and they estimated that out of 47,000 fires they looked at within homes, 50% of them could have been prevented by arc fault devices. So there's a really big proportion that we looked at.